Ever wondered about the architecture that powers your favorite Android apps? Well, whether you're an aspiring developer or simply a curious user, understanding the Android architecture can provide valuable insight into how these apps function. Let's start by introducing the main components of this architecture. At the base, we have the Linux kernel, which is essentially the heart of the system, managing the device's core functionalities. Above that is the hardware abstraction layer, or HAL, which provides standard interfaces for hardware manufacturers. Then comes the Android runtime, where your apps live and breathe, along with the native C/C++ libraries that support various system functions. On top of all that, we have the Java API framework, where all the building blocks for app development exist. Lastly, we have the system apps, the basic apps that your device can't do without. Stay tuned as we delve deeper into each component and how they interact to create the Android ecosystem. At the base of Android architecture lies the Linux kernel. This isn't just a foundation stone, it's the heartbeat of the Android operating system. The Linux kernel is a layer of software that interfaces directly with the device hardware. Think of it as the middleman between your applications and the physical components of your device. What does the Linux kernel do? Well, it's tasked with managing system resources like memory, processor time, and device drivers. It's also responsible for handling security, providing a barrier between applications and the hardware to prevent unauthorized access. Imagine your Android device as a busy city. The Linux kernel would be the traffic controller, managing the flow of data, allocating resources where needed, and ensuring all operations run smoothly and securely. It's a vital component that ensures your device performs optimally, keeping your apps running smoothly while safeguarding your data. From managing memory to handling security, the Linux kernel forms the backbone of the Android operating system. Next up in the Android architecture stack, we have the hardware abstraction layer. Now think of the hardware abstraction layer, or HAL, as the go-between for the Android OS and your device's hardware. It's a set of standard interfaces that hardware vendors must implement, allowing Android to work seamlessly across a multitude of devices. Imagine you're a phone manufacturer. You're designing a new device, and of course you want it to run Android. But you're using unique hardware that Android has never seen before. This is where HAL steps in. You, as the manufacturer, simply provide a HAL that translates between your hardware and Android's system calls. No need for Android to understand the specifics of your hardware. This is what makes Android so versatile. It can run on everything from phones to watches to cars, all thanks to the HAL. The HAL essentially makes Android's dream of write once, run anywhere, a reality. Moving up the stack, we find the Android runtime and native libraries. Let's first focus on the Android runtime, which is essentially the heart of the Android operating system. It's responsible for running apps on your device. Prior to Android version 5, the Dalvik Virtual Machine, or DVM for short, was used as the runtime. The DVM was designed and optimized for systems that are constrained in terms of memory and processor speed. It uses a just-in-time compilation approach, where code execution is delayed until runtime. However, from Android 5 onwards, the Dalvik Virtual Machine was replaced by the Android Runtime, or ART. Unlike the DVM, RT uses an ahead-of-time compilation approach. This means that the code is compiled before it's run, specifically at the time of app installation. This results in smoother and more efficient app execution, albeit at the cost of a slightly longer app installation time. Now, let's turn our attention to the native libraries. These are collections of code that are written in C or C++ and are stored on the device. These libraries are crucial for the functioning of Android applications. They include a wide variety of libraries, such as OpenGL for complex 3D graphics, Sklite for database support, and WebKit for web browsing capabilities. More importantly, the native libraries provide a platform for the Java API framework. They allow the Java code of an Android app to interact with the hardware of the device. For example, when an app needs to play a sound, it uses the Java API framework to interact with the audio library in the native libraries, which in turn interacts with the hardware to produce the sound. So in a nutshell, the Android runtime is the powerhouse that runs your apps, while the native libraries provide the necessary support and resources for these apps to function. They work together to ensure that your Android device can run a wide range of apps smoothly and efficiently. Android runtime and native libraries together form the engine that powers your favorite Android apps. At the top of the Android architecture stack, we have the Java API framework and system apps. In the grand scheme of Android's architecture, the Java API framework and system apps are the final layers, the icing on the cake, if you will. They play a crucial role in determining how users interact with the device and the applications on it. The Java API framework is a set of pre-written classes provided by Google to help developers create Android apps. These classes provide functionalities for various system services like the user interface, telephony, sensors, and many more. Let's think of these classes as building blocks. Just like a child uses blocks to build a castle, developers use these classes to build their apps. The beauty of these pre-written classes is that they save developers a lot of time and effort. Instead of having to write code to manage basic functions such as screen orientation or button clicks, developers can focus on the unique aspects of their apps. Now, onto system apps. These are the core applications that come pre-installed on any Android device. You'll recognize them as the dialer that you use to make calls, the Contacts app where you save phone numbers, the camera app that you use to capture memories, and so on. These system apps are the basic tools that allow users to perform essential tasks on their Android devices. They're built using the same Java API framework that's available to all developers, demonstrating the power and flexibility of the Android platform. Moreover, because these system apps are just regular Android apps, they can be replaced or enhanced by third-party apps. This means that if you don't like the built-in camera app, for instance, you can download a different one that suits your needs better. So in essence, the Java API framework and system apps are the user-facing components of the Android architecture. They are what make an Android device, well, an Android device. The Java API framework and system apps are what you see and interact with every time you use an Android device. Now that we've explored each layer, let's summarize our journey through Android architecture. We started at the bedrock, the Linux kernel, which serves as the foundation of Android, providing essential services like security, memory management, and process control. It's the bridge that allows hardware and software to communicate. We then moved on to the hardware abstraction layer, or HAL, which acts as an interface between the hardware and the higher layers of Android. It standardizes the communication, ensuring that Android can work seamlessly across a variety of devices. Next, we delved into the Android runtime and native libraries. The Android runtime, with its core component, ART, enables apps to run smoothly and efficiently. On the other hand, the native libraries provide a range of Java-based interfaces for Android development. We then ascended to the Java API framework and system apps. The Java API framework provides the building blocks for creating Android apps, while the system apps are the applications that come pre-installed on your device, like your dialer or calendar. And there you have it, the layered cake of Android architecture. Each layer with its unique role, all working in harmony to provide a comprehensive and versatile operating system. Understanding the Android architecture stack is crucial for both developers and tech enthusiasts who want to make the most out of their Android devices. We've just journeyed through the complex world of Android architecture. If you found this exploration fascinating, why not share this video with your peers? You know, those who share your curiosity for Android development. And if you found value in this video, show some love by hitting that like button. It helps a lot. Lastly, do consider subscribing to this channel. We've got plenty more tech content lined up for you. Don't forget to hit the like button and subscribe for more insights into technology. Thanks for watching.